See this button? Looks completely harmless, right? Let's click it and see what happens. Nothing. No pop-up, no redirect, boring. But what if I told you that this click actually pressed a button on a completely different website? Not here. Here. A totally separate website within another domain. And this button doesn't look harmless. It deletes your account on this website. Sounds unbelievable, right? Like, how can one website control another like this? Well, it used to be possible, very possible, and this attack is called clickjacking. Hi, I'm Dmitrii Balakin, and today I'll show you how attackers abused this trick and how modern browsers finally learned to fight back. Now let me show you what's actually happening behind that innocent show comments button. This is the page you just saw. A single nice looking show comments button, and under it you'll notice an iframe. This iframe is the other website, the one that actually receives click. Right now it's invisible because opacity is almost zero. Let me switch to a version where the iframe is not fully invisible. Same exact layout, same button, except right now the iframe opacity is 0.3, meaning it's still transparent, but now we can see it. Let's reload the page. This is the same page as before, but now you can see this ghosted area underneath. That's the other website loaded inside an iframe. When I hover over show comments, I'm not actually hovering my button. I'm hovering the button on the side below it. Let me click it again, but this time watch the iframe. See that? I clicked my button, but the click landed on the iframe. That's the entire illusion. You think you're clicking show comments, but you're actually clicking whatever the attacker placed under the button. And that's basically how clickjacking worked years ago. One website quietly placing another website under your cursor. But here's the good news. Today this attack is almost toothless. Modern browsers isolate everything. Storage is isolated, cookies are isolated, local storage sessions all isolated. Let me show you a very simple, very visual example of this isolation, using the same delete count button from before. Here's the victim website by itself. No tricks, no iframes. I added a tiny counter here that shows how many times this button was clicked. So if I click it, you can see the number go up. And if I reload the page, the count stays. This is stored in local storage. The website remembers me. Now let's go to our show comments page. The one embedding the same site invisible under the button. Look at the count inside the iframe. It's 0. Let's check the real site storage. Here's in local storage you can see the value. It's at 3. Now let's check the same thing but inside the iframe context. Completely different number. The iframe version of the website has its own storage bucket, isolated from the real one. This is an intentional browser feature called stored partitioning. Modern browsers split storage depending on how a website is opened. Top level tab, one storage bucket. Embedded iframe, completely different storage bucket. Which means if you are logged into the real site, the iframe version doesn't see your session, your cookies, your local storage, basically nothing. It's a blank, isolated version of the page. But here's the interesting part. This wasn't always the case. A few years ago, browsers didn't isolate storage like this at all, which meant the iframe could access your real cookies and your real session. So in the next part, I'll show you the same demo in two browsers, a modern Chromium and an old Chromium from 2020, version 85. And you'll see exactly how different things were back then. Alright, I've set up a small Ubuntu virtual machine, so I can show you exactly how browsers behaved before and after storage partitioning. Let's start with the modern one. Here's the victim site as a normal top-level page. If I click the button, the counter goes up. And if I reload, the number stays. That's normal, the site is reading its local storage. Now let's open the attacker's page. And reload. You can see the victim site loaded inside the iframe under the See Comments button. And look at the counter, it's 0, even though I already clicked the button on the real page in this browser. That's storage partitioning. Top level tab 1 storage bucket. Embedded iframe completely separate isolated bucket. Modern Chromium does not let the iframe see your real session on your real storage. Now let's run the exact same demo but in Chromium 85 from 2020. First, here's the victim site again. Same page, same counter. If I click it, the number goes up. This part works exactly the same. And now look at this. Inside the iframe, the counter is exactly the same as the real page. There is no isolation at all. If I click the Show Comments button, the iframe counters goes up, and so does the counter in the main tab. Chromium 85 shares storage between top level and iframe. Same local storage, same session, same everything. And this is why clickjacking used to be a real problem. If you were logged into a website, the attacker's iframe was logged in too. Your cookies, your session, your storage, all shared. One click on a fake button could press a real button on an authenticated page. Modern browsers fixed this with storage partitioning, what you saw in the first demo. But there's another protection layer. Websites themselves can say, "Don't embed me," and that's where X-frame options and content security policies come into play. Let me show you that next. Okay, so storage partitioning is great. Modern browsers isolate your session, your cookies, your local storage. That already kills a big chunk of what classic clickjacking could do. But there is a catch. Even with storage partitioning, other websites can still embed your pages. They can still put your UI inside their layout, put stuff on top of it, confuse the user, trick them into interacting with your site in their frame. So as developers, we still need to say explicitly, "Do not iframe me unless I trust you." I've prepared 3 branches to show how to do that properly in Nginx. First branch, X-frame options. X-frame options is the old school header. It's been around forever. Even legacy browsers understand it. Here I'm using deny, which means no one can embed this page. And now if attacker tries to load my page in an iframe, the browser refuses. Before, let me reload Nginx. Okay, and now I reload the page. The iframe is just broken. Second branch, the modern way. Content security policy with frame ancestors. Here I'm saying no one can frame this page. In a modern browser, this does the same thing. The frame is blocked. Let's reload Nginx and reload the page. Content security policy is much more flexible and is the recommended way for new projects. And third branch, both headers at the same time. This is what I can recommend for most sites in 2025. X-frame options for old stuff, old web views, random legacy browsers, content security frame ancestors for modern browsers and more complex setups. If your browser only understands X-frame options, you've covered. If it understands content security policy, also covered. Okay, let's restart Nginx and see. Works. So from a developer standpoint, the picture looks like this. Storage partitioning, great. The browser isolates your session and storage, but it doesn't not stop other sites from visually embedding your UI. X-frame options plus content security frame ancestors, that's your way of saying, my pages should not live inside someone else's iframe. If you're building anything that handles accounts, money, settings, or anything sensitive, please assume someone will try to overlay your UI in an iframe. Send X-frame options and content security policy with frame ancestors. Browsers got much smarter, but they still expect you to say whether your site is allowed to live inside someone else's page. Thanks for watching. I'm Dmitrii Balakin, and if you like these deep dives into real web security, you know what to do. See you in the next one.